Okay, so David came yesterday and he dropped off his base station for service, and it is a Harrier CBHQ in disguise. It's a Harrier CBHQ which is called a Midland 76900. So the difference between the two is the front panel. The Harrier CBHQ was $129.99 and these were $379.99. And you have to weigh up whether you think the front panel's worth the extra 200 quid, which in my opinion it is. It's very nice, but it's still exactly the same as a Harrier CBHQ. Now, something I'm going to be interested in is, does this have the extra receive circuit that the Harrier has or not? Now, what I did say is I'm going to do the capacitors on this, whether it needs it or not. By that I mean the ones in the power supply. So we'll no doubt have to take the bottom off, but we'll start by just taking the top off. And what I'm hoping is we get something a bit better for him range-wise than what he's getting at the moment. He told me he swapped this for an Amstrad. I don't know which model, but he swapped it for an Amstrad, and he had to put the bloke's aerial up as well. So it was, you have this base station and you give me an Amstrad, plus you have to put my aerial up. So there's a bit of work went into the payment, and I would no doubt going back quite some years. There's always an interesting story. But anyway, David didn't pay £379 for it, which is quite nice. Now I'm going to put this case lid somewhere safe because it's so nice condition. I'd hate it to fall all over my scruffy floor. So yeah, we've got the extra receive circuit in this. Most Cybernet 134s don't have that can. So I can see that that capacitor is receding its heat shrink, so this is what it's about. We're going to do the 3 capacitors on the power supply, and I don't think there'll be any need for anything else. So, what's this do? I've not seen one of these boards before. We do have a full service manual just in case we get stuck. Does it have a built-in SWR meter? And that's it. Well, we're going to have to take that bottom off, aren't we? Because we've got to do those capacitors. When I was at Nottingham Radio, it says here, refer to qualified personnel. I used to have all my certificates across the wall in the reception. I left there in when? 97, something like that. And I've still got all those certificates in a box somewhere. Okay, so what we're going to do is we're going to check how well it's working for a start, and then we'll write down that, and then let's hope we can make some improvements. It has 13.2 inputs on the back. It once came from Tower Communications at Haddenham, Cambridgeshire. I remember that place. I drove there once just to see what they did. January 1982. But what I don't want people to do is to think that by having a lovely switch front panel like this, that this radio in some way works better than, say, the Rotel 230 we use as the test radio, because it doesn't, it's the same. It's a shame nobody seems to be doing base stations at the moment. The last one, was it the Team 8000 Pro? We've got two of them. I've yet to see one of them work, but one day we'll probably get one of them to work. But at least they were made as a base station. Just plugged it in. It's a bit of a short mains lead. So, we'll get a piece of paper. We'll rest on a couple of service manuals. So, Midland 76900. We've got a Midland 76300, which was a pre-production prototype. It never was released in the UK, which is a Maxon-made set. We never saw the 76200, which was promised, but like a lot of sets in 1981, were promised but didn't actually happen. So, switch on. Now, where did I put his mic? Oh dear. So he's got the factory original mic with the factory original plug. Okay, here we go. So if we can find it on the knob switch. So I'll start off on the 3-watt scale. We'll switch picture in picture on. It's well across from that, and it's actually doing 3.5 watts, just under 3.5. We'll call it 3.5. Let's look at the deviation. Wow, it's virtually spot on. Deviation equals 2.6, so it just needs to pop down a fraction. And what else have we got? Frequency. Let's go over to that on our camera. It should be 27.79125. It's virtually there, isn't it? It's 27.79106. The test set has only been on 10 minutes, so I'm not going to make any frequency adjustments till the test set's been on half an hour. Right, let's look at receive. We have done this type of set before because we've got one and I've done a video on it. Okay, so let's look at the Cynad meter. Let's switch the Cynad meter on. We better plug in the instrument speakers. Not sure, I think that's the one. I think you have to switch it in, don't you? Yeah. Okay, so for 12 decibel, it's doing a very good 0.24 microvolts. We're very unlikely to improve on that. So it's 0.26 microvolts for 12 dB Cybernet. Good. So what we'll do, switch it off, and we'll start with doing the capacitors in the power supply. I've made sure that I've got that big one in stock, because I have to order them. They're not something we carry. I think they're about £3.50 for the quality we buy, so I don't want to have that many in stock, or I would be skinned. So we'll pause the video. We'll change those capacitors. Okay, roll on 24 hours. I've ordered the correct kind of capacitor from RS Components. We thought we had these in stock, but they're a different value. So clearly strangely, it's a smaller value in this. We got ordinary capacitors, which were 105 degree and 2200 and 35 volts, because we're upping the voltage as we always do. But we hadn't got what they call snap-in ones, and I don't know, especially when it's somebody you know so well, you don't have to be putting parts in which look like they're a body even if they're not. The one that's come out, as Panasonic, isn't it? TSW. And we're putting in an EPCOS, whatever that is. I chose this out of RS's catalogue because of the best ripple rating. So look at that, it's exactly the same size. That's what you can do these days with the online catalogues. So we're putting in 2200 microfarads at 35 volts, 105 degree rated. We've taken out 22 microfarads at 25 volts, which is 85 degree rated. I've no reason to believe that this is faulty, but it's time to change it when it's been in a product for 38 years. See what the meter says. It's a bit lower than you'd expect. Anyway, it's not something we want, so put that in the vertical filing cabinet. The other one we'll test is the 100 microfarads one I've taken out. And what's this? 100 microfarads at 25 volts. Again, it's Matsushita. Very similar symbols, you know, aren't they, between Matsushita stroke Panasonic and Mitsubishi. Now this looked like it was bursting a bit. 109, no, it was alright, but you know, again, it's time to change. And that's got a Nikon in. Okay, so we'll put this in. Put that in normal position. I have to move the camera across. You've got a choice of different holes so that various capacitors fit. And I've just put that in the right way round. Pause video. First thing I'm interested in is what the power supply runs at before it goes to the regulation part of its circuit. So what voltage is actually presented across that capacitor? Because a lot of power supplies like this start off around 26 volts. So if it's a 25 volt rated part, that would be a poor show. Okay, so switch on. Let's see what we've got. It's above 20. No, it's 22.2. So it's not a big margin, and that's why we go for a bit higher rating. So we'll now see what's coming out. I'll put that flat because I can't see it on the monitor. I think that's the test points there. Not necessarily. We'll get our prod on there. Yes, that's the 22.2. So if that's ground, I've got to push the off switch with my fat tummy. Try again. $13 dead. And of course that will have changed because we've changed the capacitors. So if I can get the trimming tool in, I might just have to touch that by hand. I'm in danger of pushing this off switch yet again. There we have 13.8. Where is it going on the radio then? There? Yeah. So it's 13.6 presented to the radio. Okay, so I'll leave the meter in there, we'll do the VCO. So on channel 40, trouble is I can't get to the can't get to the test point. So that should be 4. And like a fool, I've not got the microphone plugged in. What's going to do that is it. I'll just unplug the extension speaker. .5. we'll have it there. Back to receive 3.9, transmit 3.9. Channel 1, 2.2 and 2.2. Recheck transmit. Yep, good. I mean, yeah, it was fine as it was, but I've just set it as per manual, and that's what it's about. We've got a, tell you what has come in, and that's a oh, Rob Charles will get excited over this, my organist friend from Wales. We've got a Harvard 420M. Right, we'll put the radio back to channel 20, and we'll go through the transmitter. So I'll switch picture in picture on. Just like that. It's not showing the wrong picture though. That's the right one. Straight away we're doing 4 watts. So, amazing what changes in electrolytics in the power supply does. But nevertheless we'll be going through it properly. Peak. 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 It's a bit worn, that's all. Maximum. Maximum. Maximum, so we're out at 5.2, and then as ever we have to just refer to the manual because I can't remember which one's clockwise. There's all kinds of aid memoirs, but I still can't remember. So it's adjust 4 clockwise and 9 anti-clockwise. So we're turning 4 clockwise to achieve 4.4. This is so that the radio is balanced across the 40 channels. So that's now 4.4. The manual then says turn 9 anti-clockwise for 3.8 watts. But as I've said a million times before, we don't have to set it for 3.8 watts. We're going to set it for 4 because the people who manufacture these have to have them sent to different countries, and they can be spot checked at the docks to make sure they're in spec. And if one radio was doing 4.1 watts, the whole batch would have to be rejected. There we go. So we now got 4 watts on it. So that will please him no end. So I've gone from 3.5 watts to 4 watts. I'm going to pull it up on frequency. I'm going to recheck it at the end because the instrument's only been on for 15 minutes. It needs to be on 30 before it achieves its proper accuracy. So we'll adjust the crystal trimmer there, and we'll switch to the other camera. There we go. We're going to check low power. So a nice big knob on the front to do so. So we should have 400 milliwatts. So again, it should be there. Ah, it's not. Well, these tend to get dirty. 400 milliwatts. Switch back to normal. And that deviation was a bit high when we checked it before. Wallow. It's very marginal. That's in the wrong position, in fact. Let's try it there. Wallow. 1 2 1 2. And that wants a bit more, you see. One, two, wallow. Wallow. Still needs a bit more. Wallow. 1 2 1 2, wallow. 1 2, wallow. That's about right. I think he uses it with a desk mic, but at least now it the way the mic gain is how you'd expect. Okay, that's deviation. So power on the power meter. How am I going to show you this? I'm going to have to tilt this monstrosity. So it says 5 watts there. You can't even see that. I'm just looking at the monitor. I'm going to have to move the camera across a bit further. So it's that one we're talking about. So that one's dropping down. That's another dirty one. So that's somewhere near 4 now. Oh, dimmer. Oh, yeah. Well, I reckon that's transmit done. So we'll move on to the receive, which we'll see what it's doing. We better plug that extension speaker in. I must have plugged it in the wrong one. I have. There we go. So the first thing we'll do is put an S9 equivalent signal on, and we'll look at that on the oscilloscope. Turn the bench light off so you can see it, and just like that. Just the detector. Very small improvement there. Now we'll go through the front end. So go to the cyanide meter. Drop the signal. That'll do. Minute adjustment there. The stage we don't normally have on set. Spot on. Spot on. Spot on. Bigger signal for the others. and a different tool. It's fine. Minute improvement there. The biggest still signal on. Okay, so we're now reading 0.24 microvolts for 12 dB. It was excellent as it was, but we've just got rid of that little bit of noise. You might get an extra 3 inches range. So, let's look at where S9 is. Tilt up the beast. You know what? It's virtually spot on. I'm going to give it the very slightest turn down. There we go. And now it's squelch time. So we'll turn the squelch to full. Advance the signal generator, and I'll put the attenuator controls on so you can see. So that we have 100 microvolts, equivalent of S9, spot on. So it doesn't need adjusting. If it did need adjusting, it's the preset there. So now we'll check it that it has suitable sensitivity at the other end. So I've put the signal generator to standby and it's parked at 0.3 of a microvolt. So that's the threshold position. So let's see where it's coming in. It's coming in at 0.32. No, I'll say 0.33 to be honest. Dropping off at 0.29. Now we all know that this chassis isn't the best squelch in the world. So I'll be interested to see what the SWR meter says. Just win a dummy load. I better unplug that extension speaker. So we're done. Better unplug that and SWR. So calibrate to dirty control. So that's set position. Spot on, isn't it? 1.1. I don't think you can see the second meter. So that was calibrate, and that's SWR, and that's what you'd expect. I'll just give that a spray. It's a bit try that again. Bit smoother. There we go. That's it then. Put it back together. So I say it was just a service. It wasn't there's anything faulty. We've done the power supply. We've got the power from 3.5 watts to 4 watts, and everything else was just neither here nor there. I'm just going to check the transmit once again and make sure we're still on frequency. Yeah. So I'm going to put the lid on, wait 10 minutes. I just want that 30 minutes window to make sure that we are definitely going to have the accuracy with the test instrument. So I'll pause the video. So upon checking, it is slightly high now. Are we on? Yes, we are. 27,79129. So we'll just pop that down. So I'll leave it at 0.27, and it's not likely to drift now from there, apart from downwards as it gets older. So the next thing is I'll put the lid on, and then we'll just pop it on the aerial and we'll do a scratchy corner test. Right, we'll run through it. We're not likely to get anybody else more than we normally would, which is nothing. Well, no, Roger. There you go. Midland 76-900 base station from 1982. Very nice piece of kit, and it's the poshest Cybernet 134 they ever did. Thanks for watching.